Hello and welcome to the InteliMap Advanced Guide. In this guide, you will learn about all the different settings and what they do, and how to use the API for runtime generation. As with the Quick Start Guide, InteliMap is necessary in order to follow along. So if you've not yet purchased InteliMap, please check us out on the Unity Asset Store. As you can see here, I'm open to the second example scene that comes with InteliMap. To start, we are going to go over the settings for the InteliMap Builder. The first setting we have here is epochs. This is how many times to analyze the build maps. Increasing this will make the build take longer, but also likely produce better results. The next setting is build mode, and it dictates how the generator will be built. From scratch means that it will create a new generator each time you build. From scratch overwrite means that it will overwrite the generator to build a new one. And load from generator means that it will load the generator from the generator component on this object, and then continue to train it. This can be used to improve already finished generators. The last setting in the general section is neighborhood radius. The neighborhood of a tile is essentially the area of tiles around it that should influence what that tile becomes. Typically, a value of 2 or 3 is all that is necessary, but you may need to increase it for more complex tile maps. Very importantly, the InteliMap Builder has a list of build maps. These are the areas of tile maps that the InteliMap Builder will use to learn from in order to create the generator. An entry in this list has many properties: the map, which is the tile map to use, the commonality, which I'll explain shortly, and whether to use manual bounds or automatic bounds. If you use automatic bounds, it will include everything in the tile map. Now for commonality. This is demonstrated very well by example scene 5. A build map's commonality corresponds to how heavily weighted that build map should be. A build map with a commonality of 2 will have twice as much of an effect on the resulting generation as a build map with commonality 1. You can also set a build map's commonality to 0 if you don't want to generate maps that look similar, but you want to include that map so the builder has more information as to what connections are allowed. This is because the builder decides what tiles are allowed to be connected based on if they appear connected in a build map. Having a build map of commonality 0 gives the builder this connection information without it attempting to generate maps that look like it. Now we have the advanced settings for the builder. The starting and ending learning rates are essentially how fast to train the generator. The starting learning rate is how fast it will train at the beginning of the build, and the ending learning rate is how fast it will train near the end. Turning these settings up will likely speed up build times, but going too high with the learning rates may result in errors. Connectivity is whether to enforce connections only orthogonally for 4-way connectivity, or to also enforce what tiles can be connected diagonally for 8-way connectivity. Interpret empty as tile dictates whether to include empty tiles or not. This is used in example 6. It is used here because the generator specifically needs to place empty tiles. As you can see, I'm erasing this here. These are completely empty tiles. The blue is just a background. But when it's generated, the generator specifically places those empty tiles. Next is acknowledge bounds. This is which boundary should be used as an input for the generator. Basically, if a tile's proximity to a border should influence what that tile should be. Finally is enforce border connectivity. Checking this will only allow tiles to appear on the border if they appear connected to that border in any of the build maps. As you can see here, enforce border connectivity is set to true for all 4 borders, and the only tile to appear on the border in a build map is the empty tile. Therefore, when I run this, you can see that the only tile on the border is the empty tile. Now we have the settings for the InteliMap generator. First, it has the map to fill, which is the tile map to use for generation. The bounds to fill, which is the area to generate in. Note that generation will only take into account tiles that are inside these bounds. For example, the generator will not attempt to connect these two in a way that makes sense. This is because the tiles were outside of the bounds. If you want to make sure these tiles are connected properly, make sure their areas overlap. Next is the generate on start setting. This is a simple setting for whether to generate upon the scene starting. Next is the forceful setting. If this setting is set to true and the generator is called to generate in an impossible area, instead of throwing an argument exception, it will remove some of the previously placed tiles in order to generate. So the setting should be set to true if failing to generate is unacceptable, and it should be set to false if removing previously placed tiles is unacceptable. Lastly is the temperature setting. This is essentially how random you want the generation to be. Higher numbers will mean more random, and lower numbers will mean more consistent. Example 6 shows the comparison of how different temperature values affect generation. Lastly, I'd like to show you how to use the simple API in order to control your own generation. I'm currently in example 4, and I'm going to open up the example 4 movement script. As you can see on lines 37 and 38, we call start generation on an InteliMap Generator object. This start generation function call makes the generator generate inside of its map to fill and bounds to fill. So the only thing you will need to do in order to make your own runtime generation is to modify the generator's bounds to fill property, which is done here on lines 41 and 42, and then call start generation. There is also a clear bounds function, which completely wipes the tile map inside of the generator's bounds, and a start generation with seed function, which allows you to do seeded generation. If you would like more details, you can view them in the documentation file that comes with InteliMap. That is all for this advanced guide. If you haven't yet purchased InteliMap and would like to check it out, you can find it on the Unity Asset Store. Thanks for watching.